Welcome back. This is lesson 4 of GCSE Geography. So we're continuing along the lines of what we looked at last lesson with the hydrological cycle. We're going to focus in on a specific part of the hydrological cycle called the drainage basin. And we're going to build our knowledge of what we mean by the concept of an open system compared with a closed system. And there's going to be more key terms coming your way this lesson related to this specific part of the hydrological cycle. So when you're ready, put this title down in your books, Drainage Basins, and we'll get going. Okay, so the first thing I'd like you to do, we're just going to warm up and activate our prior knowledge with regards to what we covered last lesson. This is more commonly what a diagram might look like, perhaps in a textbook or in maybe a past paper. So what I'd like you to do is use what you learned last lesson about the hydrological cycle and apply it to this version of a diagram of the water cycle. So what I'd like you to do is ignore these old letters that are on here. Okay, so only pay attention to the red letters that I've put on. I want you to match each red letter to the correct transfer. Okay, so in the back of your books, just put the letters A, B, C, D, E, F, G down the margin and write the correct term next to each letter as if you were matching it up on the diagram. So pause the instruction here and do that, please. Okay, so here is an enlarged version. Let's have a little walk through. So first off, this area of the diagram over here, where's my arrow? This represents the seas and oceans. And the arrow coming off of the seas and oceans, for A, you should have the process of evaporation. As that evaporated moisture rises and is blown inland to around B, where it's rising, as it rises it will cool and condensation will happen to form clouds. As condensation continues, eventually all of that water vapour will fall as rain, hail, sleet or snow, any moisture coming out of the sky, we call that precipitation. Now, we talked about last lesson, once the precipitation reaches the soil, one of two things can happen. If it is porous, it will soak in by infiltration, and then the process at G will kick off. We'll come to that in a minute. But if the land that the precipitation falls on is impermeable, that means that water cannot soak in. And so at D, what this arrow is representing is surface runoff. Literally, the water runs over the surface into the rivers and streams and back to the seas and oceans. What's going on at E, this arrow coming off of some very poorly drawn trees. This is supposed to be a forest. Okay, so moisture coming off of plants is transpiration. Any water flowing in rivers and streams back to the seas and oceans, stream flow at F. And as I touched on a minute ago, if the soil is porous, then infiltration will happen. And the process under the soil where the water is trickling down through the gaps to become groundwater flow, that is percolation. Okay. So this is the water cycle that we've been looking at, just drawn in a slightly different way. So this is the one that you're more familiar with, that we drew last lesson, and this is the one we've just looked at. Both of them are a diagrammatic representation of the hydrological cycle. The hydrological cycle is what we call a closed system. Nothing can be lost or gained. We cannot lose any water out of our atmosphere to space, nor can we gain any water from outer space into our atmosphere. Not that there is any water in outer space. Space is a vacuum. So the water cycle is a closed system. The amount of water on our planet has been the same for 4.6 billion years. All that changes is where it is stored and the rates of the different processes moving the water between the different stores. Okay, so there's a particular part of the hydrological cycle that we're going to focus on today called the drainage basin, as I said. Now the drainage basin, it's just this part here. So we're basically taking out what goes on in the sky. All right, what goes on in the atmosphere, we're taking that out. We're just focusing on what happens to the water once it reaches the ground. Okay, on this diagram, it would be this area here. Okay. So if we focused in just on this part, so you've got the ground, the earth coming down from maybe some mountainous relief in the area. You've got water gathering in the bottom of the drainage basin to form rivers and streams, and then you've got the end of the drainage basin going back to the seas and oceans. And the same here. Water drains down off the mountains. You've got rivers and streams forming in the bottom of the basin, and the rivers and streams flow back to the seas and oceans. It's called a drainage basin. Think of basins that you know of in your home, all right? A sink basin. Any water that falls within the basin will drain down into the bottom and drain away down the sinkhole. It's the same in nature. That's why we call it a drainage basin. You've got this basin shape here, created by a valley. So it's kind of like the sides of this basin on either side. Any precipitation that falls within this area will drain down these slopes into the bottom of the basin and form rivers. Sometimes lakes as well, that will flow out of the basin towards seas and oceans. Just like any water that drains down the sides of this basin will form trickles in the bottom of the sink that drain away down the sinkhole. So that's why we call it a drainage basin, because it drains water away out to the seas and oceans. It's like a basin shape, just like we have in our homes. Okay. So what we're going to look at is the rivers and all these things that you've got going on here in the drainage basin. What are they? How do they change? What do we call them? Okay. So if I was to draw a cross section of a drainage basin, so as if I've cut down through the middle of it and I'm looking at it sideways on, this is what it would look like. Whoops. Okay. Let's go back. So this is what it would look like. The drainage basin is what we call an open system. An open system has inputs, the amount of water coming into the system. Water comes into the drainage basin through rain, hail, sleet or snow. Things then happen to it in between, processes and stores that we know of already, and water is then lost. It's put out from the drainage basin. It's either lost back into the atmosphere by transpiration or evaporation, or it's carried out to the seas and oceans in the stream flow, in the rivers. Okay, so whereas the amount of water in the entire water cycle, because it's the entire planet, the amount of water in the water cycle is the same, it's closed, the amount of water in any given drainage basin could change if you have heavier or lighter rainfall coming in, if you have a really hot day, so evaporation increases, if there's more vegetation within that drainage basin, so transpiration rates are higher. So inputs and outputs of a drainage basin can change, and that will affect the amount of water within it. That's why we call it an open system, because in this case water can be gained and lost. Okay, so what I'd like you to do, leave yourself plenty of space, at least half a page. If you want to take a full page turn sideways, by all means go ahead, but I'd like you to make your own simplified version of this diagram. Now when I ask you to do this in class, you quite often panic because it's in 3D. Just do your best. Take a plain pencil, take coloured pencils and make the best version you can of this diagram. Now you'll notice there's little grey spots everywhere. Okay, and I've sort of covered some things over and rewritten some things. That's for the purpose of this lesson. We only want to focus on certain parts and we don't need the other bits that I've covered up. Okay, remember we used the word saturated last lesson to mean that beneath the water table, beneath that layer under the ground, these rocks and soil layers are permanently full, permanently saturated with water, and that's where you get your groundwater flow happening. as a transfer as part of this element of the water cycle. So, task, subheading, the drainage basin, an open system. As best you can, draw some trees, draw the soil surface, draw some little streams running over the surface, going to a main river, and then put on your inputs, outputs, stores, and transfers of the drainage basin. Okay, and I'd like you to, just like they've done here with this key, colour code your inputs, outputs, storage and flows as best you can, either with coloured pencils or with highlighters, entirely your choice. But make your own version of this diagram in your books now, please. So pause and crack on with that now. Okay, what we're going to do next is zoom in even further. So we've taken out what's going on in the sky, in the main hydrological cycle, and just focused on what's happening on the ground, just the drainage basin. What we're going to do now is zoom in on just the rivers part of the drainage basin. Okay, now you have this diagram on one of the handout sheets that's in this lessons folder. Okay. This is the drainage basin from a different point of view, as if you're looking at it sort of from the sea, looking up the valley, looking up the drainage basin. So the height of the mountains is increasing towards the edge of this diagram. So this is, you've got like a great big basin shape here. All right. Now, in each of these white boxes, I want you to put the correct label. To enable you to do that, here is a table of all of the words you're going to put in the boxes with their definition next to them. Okay? Reading the definitions, you should be able to identify where on the diagram the words should go, but I'll give you just a little verbal breakdown quickly anyway. So if we start at the very beginning, the edge of a drainage basin, it usually marks the boundary between a couple of valleys. So the land would be rising up here to like its highest point, and then it would be dropping away on that side into the bottom of another valley over there somewhere. Same on this side. The land would be rising up, reaching its highest point, and then dropping away on the other side into the bottom of another valley next door. This highest point, the edge of the drainage basin, we call it the watershed. Think of it like a shed roof. The highest point that marks the middle of the roof. Any rainfall that falls on this side will drain into this drainage basin. Any rainfall that falls on that side will drain into next door's drainage basin. Okay, so that dotted line marks the edge of this drainage basin, the sort of highest point around the edge of the valleys that make up the basin, and the line that decides which way the water is going to go, if you like. The start of a river is called the source. And you've got lots of small rivers within a drainage basin. They're called tributaries because they contribute, they add water to the main river channel running down the centre of the drainage basin. The point where two tributaries meet is called a confluence. The point where any rivers meet, in fact, is called a confluence. The bend in a river is called a meander, and the flat land either side of the river is called the floodplain. The river creates that naturally for itself, so that in times when it has too much water in its channel, it can dump a little bit on the sides, it can flood the flat land around it while it deals with all the extra water, and then the water will drain away from the floodplain into the river and out into the seas and oceans. So the flat land either side of a river is called the floodplain. And the river uses it to help deal with extra flood water when there's particularly heavy rainfall. Towards the end of the river, where it reaches the seas and oceans, as it starts to widen, it creates an estuary. Now, this is where the river will start to slow down because it's filling a much wider area. So any mud that it's carrying, or pebbles and stones, because it's the water is trying to fill a larger area now compared to up here, say. The channel is much more narrow. It loses a lot of energy and it can't carry all of that mud and stone anymore, so it drops it. So around here, you get a widening, muddy area of the river called an estuary. And then right where it reaches the seas and oceans, we call that the mouth. Okay, so feel free to go back and replay what I've just said, along with the definitions that you've got here, to cut, label, and stick this diagram into your books, please. So pause the video now and do that. All right, the final task for today is drainage basin key terms dominoes. So to make sure that you have got the meanings of the key terms you've just used to refer back to just in case, I've created a game of dominoes. Now, I'm assuming you guys are familiar with the concept of dominoes. It's where you have to, one end will match the end of a different domino. Okay, so a domino is one complete rectangle. Okay, I know these are set out in kind of a strange order with random gaps between them. But what I'd like you to do is cut out each of these. So that would be one, that would be one, that would be one, and so on. So cut each of them out. Do not cut across the dotted line. That's just marking the middle of the domino. Cut each of them out, only around the bold lines, not the dotted lines. And then beginning with the one that says start on it, stick that in the top left-hand corner of your book. And then the key term on that domino is tributary. So you're going to look on all your other dominoes for the meaning of the word tributary and stick that one butted up against that first one, so that the key term is stuck next to the meaning. And then on the other side of that domino will be another key term. And you'll have to do the same. Find the domino that has the meaning that matches that key term, stick it down, and so on until you get to the finish. Okay? Use the previous page's table to help you if you need to. And you might, to get it all to fit on one page, you might have to sort of create some sideways so that it sort of snakes around the page to keep it on one page. If you end up going across onto another page because of the way that you've stuck them, don't panic about it. It's no bother at all. All right. If you're having issues with scissors and glue, then by all means, if you want to, you could always perhaps instead copy down the definitions next to the meanings from here. But it doesn't get you to think as much as doing it this way. This is more of a problem-solving approach. Okay. Once you've done that, that's lesson 4 done and dusted. We're going to start looking at flooding in more detail over the next few lessons. So sticking with the water theme. And as usual, if you have any questions or queries or worries or concerns of any sort, drop me an email on Hub. Like I said, I'm the only Gleason A on there. So there's not even any numbers or anything following my name. It's just gleasonaat@hubcymru.net.